Hey everybody, welcome back to the Adventures of Blink. I am of course Blink and you can find me on GitHub right here. Now, before we get started, I want to make sure you remember to like and subscribe and click the notification bell and do all the things so that you don't miss any episodes. This season has been one long build. That's kind of the way that I like to work, is to give you one idea that we're going to work through for the entire season. And so I don't want you to miss out on any of the steps through the process, lest you get lost along the way and not be able to catch up. So today's episode is sort of a fast forward. We've been building our way through this project. We're making Hangman in Python. But one of the things that I ran into was that there's a lot of code that goes into making the game work, and this wasn't really supposed to be about the code per se. What I wanted to focus on was the ability to use lots of different DevOps tools and sort of model them in a relatively small application. So I made the choice to get out of the coding part, and I'm just fast forwarding through that. So I'm building it, but we're not going to spend a lot of time looking at how we assemble the project itself, so much as how we use the other tools to enhance our development capabilities. And that's what we're going to really try to focus on for the rest of the season. There will be a little bit at the end where we go back to the code, particularly around the idea of AI. I'm looking at what would it mean to have a language model contribute to the game boards and make new ones to be able to play on a regular basis. So we'll look at that, and that'll be sort of a coding example, but that's also sort of, it's not necessarily like straight Python. That's about learning how to hook up to an AI product. So that kind of stuff is where my head's at. You'll notice there's a ton of code that gets pushed into this episode's branch on GitHub if you check out the GitHub link. And I don't want you to feel like you got lost along the way. Why did we suddenly have all this code appear? I'm not going to cover that in detail. So before we get started with today's DevOps tool that we're going to plug into our process, I wanted to take a minute to go through that fast forwarded code, just to highlight some interesting things that happened as I was doing it. There were some DevOps techniques that sort of stood out to me in the coding process that I found useful and helpful, and I wanted to make sure that you've got an awareness of why it is that we do all those things. I know sometimes it's hard to relate to big enterprisey DevOps techniques when you're working on a tiny project like Hangman, but I think this illustrates it really well. So let's take a look. All right, so what you see here in the code is the game class, and I ran into a bug as I was starting to test this out. It was something that I missed in the unit testing, and as it turns out, it was sort of a weird situation. When I started up the game, everything pops up, and then it smashes all of the words in whatever phrase it picks. So even though the game was technically working, it wasn't making it easy for the player to experience the game the way it's meant to be. So it wasn't respecting the white space in the string. And I realized that I needed to find a better way to handle that. So the first thing I did was to modify my test case. And so we'll go over here to the tests, and we'll see, if you notice, my original fixture only had a one-word game that it tried for the testing purposes. And I realized that was a little bit of a failure on my part. I should have had more cases. So I built a new fixture where the phrase that's being used in the game is 2 words. And I have a space in there so that I can see on purpose. And that required me to do some changing. First of all, I needed to be able to assert off of both of these. And I didn't see the need to necessarily test literally everything about both of them. I only wanted to test the display word to make sure that white space appeared in the display word text so that there was a way to validate that. And that was really the only change I made to the test, but that was enough for me to be able to work with as I went back into the game. And so where I found the problem to exist was in calculate display word and reveal letters. So first of all, I was only using letters as a valid component. And so I wanted to make sure that I respected any punctuation that was stored. And so I had to change my regular expression. You can see line 41 is a little bit more complicated than the original version. If you go back even to last week's episode, you'll see the difference in the two of these in the code. And then reveal letters, I needed to add another conditional down here on 52 to be able to check to see if any of those spaces or punctuation marks existed in the code. And if it does, then I need to make sure that they come along for the ride. Because I also ran myself into a case where the display text was putting an underscore in the place of the punctuation that was being used. And that was kind of a problem because that meant you were supposed to guess the punctuation in order to clear that square or to clear that character. And the inputs did not allow you to use anything except letters and numbers. So I had to do these two fixes in order to make everything work better. But what was really interesting to me about this process is because I started by changing my unit test, I had an instant way to validate that I had fixed the problem. And so it was really easy to be, I went through several iterations on this to make sure everything was right. And I got some help with the regular expression to make sure I got the syntax of it correct. But going through that process, I was able to instantly test after each change and see if I had actually succeeded at meeting, my desired state. So another thing that was really interesting about the way this is designed is that having the game in its own class here made it really easy to integrate with the front end. So I don't know if you've ever built a lot of front end things, but as you're building those forms, sometimes it can be complicated to know when I need to feed it data and when I need to just build the form and get it working, and then I can sort out the data things later. In this case, I was able to build out the entire layout of the screen and have it all blank, have it filled in with junk data just to see how it laid out. And once I had that done, it was really simple to come back and add my class in and let it feed the data to the different places that it needed to be displayed. So having the entire game state in its own class was a really valuable technique because of the way that I was able to integrate with the front end. Now, again, in a small case like this, you're building Hangman. It's not all that important in the grand scheme of things. But if you think of this in the process of scaling up to enterprise software, you as the game developer may not actually be writing the front end code. You may have a front end person or team who builds the look and feel of the game, and you're just there to focus on the game logic. So being able to compartmentalize like this and separate those concerns was really important, and it made it really easy to integrate after the fact, because then I could just hand the game class over to the game board and say, here's where the game's going to be running, and all you have to do is feed in the values from it to know what happened, and then feed in your inputs when things change. So the final thing that I thought was really important about the way this all shook out was that it alerted me along the way to some sloppy code that I was writing. You may be shocked to hear that, but even some of the things we did in the last week or two have been really sloppy code. And one of the things that stood out to me there was if you look at our game editor, so the original version of this had a ton of HTTP requests in it. We just made the methods on the screen. When it was ready to get data for the screen, it would just directly call the API and pull that in. And again, in a Hangman game, you can get away with that because it's very small overall code base. But In enterprise software, this could be a really dangerous thing because it makes a maintenance nightmare later on. Now the screen is directly tied to the API, which means that any screen changes might necessitate API changes, or any API changes might necessitate screen changes. It really couples them together in a bad way because you don't have any flexibility in the way that you do your code. What I ended up doing, as you can start to see here, is made some changes to the idea of using the DB API. So we threw that together when we were first testing end to end, I think it was 2 weeks ago. And I realized that I needed to separate concerns better, and I needed to double down on the use of that DB API. So I took out all of the references in the editor to the API. I took out all of the like request information, all of the HTTP work. None of that occurs in the editor anymore. What it does instead is call this DB API, which has all of that stuff built into it. So all of the API methods are now listed. Instead of just having the one or two that we were testing with, I went on ahead and filled out the rest. And then I made it so that all of the methods are there. And so when you need to call the database for something, you do so by adding this class. And so if you go back here to the game, well, not the game, I'm sorry. If you go back here to the game board, you'll see that we use the integration to be able to pull the data in and construct the game board. When you look at the game editor, we did the same thing. And so being able to just drop this class in is how you now have it so that you don't have to keep repeating yourself. The whole goal here was to make it so that I write the database code, the API calls, one time for the whole application. And that way, because I now have two places that I would have to change, I've simplified that to have one place that it changes. If there's an API call that changes, I have to go to just the Hangman DB integration and make that fixed, and then it's good for the rest of the application. It's very important to separate concerns like this to make sure your code is what we call loosely coupled. And that loose coupling gives you the ability to change things out easily. I could come along with a different kind of database if I wanted to change it from Mongo to Postgres and have to rewrite the whole API. I could totally do that behind the scenes, and the game wouldn't change at all. It would just be that one class that handles the integration. Or maybe I introduce the ability to use both databases in some way and choose. Then DB API would be the interface that the rest of the game uses, where it says, oh, if I ever need to add a phrase, I just know I call the add method in there. And it doesn't mean that I now have to change the entire structure of what's going on. So moving on to today's topic, we're going to talk about security. And again, this might feel a little weird because we're talking about a Hangman game, but I want you to put on your enterprise software glasses and think about this as an example of a larger project, right? It's just been scaled down so it's easier to manipulate. We're using a lot of code in our project that we didn't actually write. There's Mongo database, there's the Flask framework, there's the Python runtime itself, there's the requests library for HTTP calls. There's a ton of code in there. Those are not small things. They're expansive libraries, but I didn't write any of their code. I can't necessarily guarantee that their code is safe. What if one of them had a vulnerability in it? Then my product is vulnerable, even though I wrote really good code, or so I feel, right? I only wrote a tiny little sliver of this big application, and it's important that I have some sort of visibility into all of the things that are in my software supply chain. So how do I get ahead of that? How do I maintain an awareness of all of the libraries and all of the things that I'm building upon? If you think of them as like little platforms that I'm stacking on top of each other, and then I put my tiny little bit of code on top to make my application, I have this mountain underneath me that I have to maintain. how can I do that easily? Particularly if I'm, a very small time developer, I'm one guy trying to sit here and do it all. Well, let's look at a product from some friends of mine at a company called Snyk. Now, Snyk is a security tool that you can use to scan your software projects. And it does a couple of things. It's got some AI intelligence type things that are built in to be able to validate that your code that you actually wrote doesn't introduce security vulnerabilities. It looks for common patterns. And it also handles a lot of software supply chain issues. So it can keep track of all of the software libraries that are in play and make sure that it's aware of how things are changing in all of those little projects. The open source community is wonderful because there's tons of things to pick from, but that also means there's tons of things that are changing all the time, and somebody's got to keep up with that. Well, Snyk offers that as a service. So let's take a little bit of time to look at their product. And actually, we can plug it in because there's a free tier within the Snyk platform where you can try this out on small time projects like mine. So here's our Docker file in Snyk where we can see what the situation is. First of all, the current image that we're using is Python 3.12 Slim, and it has 41 vulnerabilities, 1 critical, 1 medium, 39 low. We can upgrade to 3.13 Slim, and it will eliminate 4 of the low vulnerabilities. So they've fixed 4 of these problems just in the latest version, and if we upgrade, we take care of those problems. Unfortunately, they don't seem to have fixes for the critical and the medium yet. So let's take a look at what those are. If you scroll down here a little bit further, you can see zlib has an integer overflow or wraparound issue. It was apparently found in 2023, and there is currently no remediation path available. So this is a vulnerability in the code that we're not going to be able to fix. However, we can know that our application does or does not use zlib. It's probably just included because it's part of the Python runtime, and it may not be a feature that we're actually using. So now that we're aware it exists, we know what to watch out for in what we're doing. Okay, so now that we've gotten a little bit of a look at this, unfortunately there's not much we can do to repair our application. We do have the option here, you can see, to upgrade to 3.13, and Snyk will actually help us with this. If you click this button, it will take you to a page where it starts to open a pull request in your GitHub repository that fixes the problems. Which is really super cool. It's amazing that Snyk can actually not only detect what's wrong, but it can suggest the fix and put it in place for you. And that would eliminate 4 of these low vulnerability issues. But I don't know that that's necessarily worth following up on at the moment because they're low vulnerability and we're not necessarily using much of the Python runtime. It's just a few things that we have kind of at the top. So let's go back to our project and see what else there is. Let's go to this requirements. So the API requirements.txt, if you remember, requirements.txt is the file where we decide what libraries we're actually pulling in because we need to use them in our code. So let's take a look at what it's found here. There's 2 mediums. And so if we scroll down here, let's see. DNS Python and PyMongo have some problems within them. And so you can see that this DNS Python issue was introduced through PyMongo 4.5, and it's been fixed. And so PyMongo also has its own problems, or its own separate problem, and it was introduced in 4.5, and it's been fixed in 4.6.3. So as it turns out, we were using an out-of-date version of PyMongo. If we fix this vulnerability, then we can actually take care of both of these in one shot. So let's walk through what that looks like. If I hit fix this vulnerability now, so there's open a fix PR. It's going to open it in our project. to change the requirements.txt. And so you can choose which issues you want to fix. It says, hey, I'm available to fix both of these. And so I'm going to go on ahead and click that. And let's go see what opening a fixed PR looks like. So here is the pull request that Snyk has made for me. It's opened up a PR in my project. It created its own branch where it made the fix, and we can go see the files that changed. So it's actually updated that. I can make a review on this, and so I can follow all my normal pull request procedures. But I do it based on Snyk actually providing new code for me to work with. So it made the updates, and it's suggesting that I check the changes in the PR to make sure it won't cause issues with the project. And it's put a warning here that says PyMongo 463 requires DNS Python, which is not installed. So I may actually have to make further changes in order to get this to work. But it gives you instant links to all of the places. Like you can go to Snyk and you can see how the project has been scored. You can see there's the verified check, so it's actually done this. And security Snyk has run. And let's see if we can see the details. It'll pop us back over here. And it says, hey, after you make this change, we will not have any issues reported in the Snyk product. So that's kind of cool. It's actually able to solve the problem. And then if I'm ready to go, which I'm actually not because I need to find out about that DNS Python issue up here. But if I was ready to go, I could merge this right away. And so Snyk has just taken care of my code for me. It's helped me manage that software supply chain that's behind me. All those things that I'm building on that I'm not necessarily aware of what's going on. It's been following along with those projects, and it's given me some insight. So what a fantastic tool. You actually have the ability to instantly see what's changed in my code. Now, I had to take just a minute to come back here to the Snyk scan of my project because I was really proud that if you look at the code analysis, which is the code that I have written in the project, it sorts these out. And so it shows you like, here's your Docker file, which, we're building out of containers that are not always our things. And it has the requirements, which are the supply chain issues. But it says, hey, I'm analyzing your code that you wrote. And I was really proud to see that there are no issues for this project. So I wanted to take just a minute and brag on myself a little bit, right? That I put this out here and Snyk did not find any problems with my code. It found it in libraries that I was using, but nothing I wrote had any vulnerabilities. So that gives me a little warm, fuzzy feeling, right? Super awesome to have all of this on a dashboard where you can see everything together. It's often something that developers struggle with is getting excited about the idea of keeping their code secure. It's usually not top of mind because when we're writing things, we're usually trying to make features work. We're trying to make something new. We're trying to get it to just compile successfully and do the thing we wanted it to do. And we're not necessarily concerned with, are we being safe? Are we keeping our data secure? Are we protecting ourselves against the bad guys? And in a hangman game, of course, it's not going to apply very much. But in your day-to-day builds for actual work assignments, this is critical information. This is the way that software engineers separate themselves from the herd, so to speak. If you can be security conscious, if you can build safe products, you set yourself up for a great deal of success. And if you have awareness of what you're doing in those security spaces, that sets you apart from the rest of the community because there are so many developers who are just there to write features and they're not necessarily thinking about the big picture of keeping everything safe. So I hope you've enjoyed today's journey through Snyk and plugging it into your GitHub repo and being able to try out things that can scan your code and help you stay safe and secure. It's a fantastic product. I'll make sure there's a link down in the description where you can go follow along and learn more about the product. We barely scratched the surface of it today. It does so much more. But this is what we had time for, and this is what I wanted to build out today. So I hope you've had a good time with it. I hope you've learned from the experience, and I can't wait to see what you build and how secure it is when you get done. We'll see you next time.